Hi, my name is Prakhar Mehrotra, and I'm the Vice President of Machine Learning for the Walmart US business. It's an honor to represent Walmart at the prestigious Edelman Awards. Today's presentation is about a novel approach that we have developed called the Dynamic Clearance Markdown. It's an idea that combines principles from operations research and machine learning to tackle one of the most challenging and prevalent problems in retail of that of finding an optimal price discounts to clear the unsold inventory. So what is markdown? So markdown is a retail term that refers to a reduction in price because we want to accelerate the rate of sale of this unsold inventory. A 20% price reduction because a retailer needs to sell off that old iPhone to make way for its latest model is an example of a markdown. The term clearance means that we need to completely sell the excess inventory within a specified period. That's the reason why we term the algorithm dynamic clearance markdown, because we need to figure out the right timing of these price reductions so as to clear all of the unwanted inventory. Now, every solution we build ties back to the vision of our founder, Mr. Sam Walton, to serve our customers. So, before we take you through the immersive journey of Markdown, let's understand Walmart's core values and culture by watching this iconic video.
As important as any other one factor is taking care of our customers, exceeding their expectations.
Those customers are the only reason for our being. Don't you all realize that? They're the only reason we're sitting here today. Our customers are more important to us than anyone else.
And if we're good merchants, we'll always be the best retailer. We are truly a merchandise-driven company. We always have been. We always will be.
And if we are good merchants, we'll always be the best retailer. This line from our ex-CEO, Mr. David Glass, along with Sam Walton's core value to serve customers, forms the basis of why we developed a new way to do markdowns in order to make merchants more efficient by giving back that time. I want you to remember two more terms that will be often used in this presentation: modular and automated modular transition. We will have detailed explanation of each in this presentation, but for now, just remember the following. Think of modular as a shelf or an aisle on which items are stacked. Since the space in the store is finite, so as the seasons change, we need to replace old items with new items. For example, we need to replace summer t-shirts with winter jackets. This process of changing items is called modular transition. The term automated means that we want to automate this process of transitioning. And one way of doing that is via clearance. Next, you will hear from two of my colleagues, Scott Plyman and Nate Lyman.
Good morning. My name is Scott Plyman, and I have the pleasure of leading merchandising operations for the Walmart US business. My team is a key player in driving the underlying strategy around pricing and replenishment for the world's largest retailer. It's a task that none of us take lightly. Our customers are at the center of what Walmart does every day. We are a merchandising-driven company, and we're fueled by innovation. Today's presentation is no different. We are proud of having created an automated modular transition process utilizing machine learning to institute dynamic markdowns to both optimize sell-through and reduce cost. At Walmart, our biggest point of difference is our commitment to run everyday low prices in an industry that's dominated by high-low pricing. Prior to the start of COVID-19, Walmart saw more than 140 million customers in our stores each week in the US, and more than 90 million unique visitors each month online. Busy families looking to save money and time. Saving up for that new 4K TV and finally hanging it on the wall. Granting birthday wishes and enjoying the smiles on their kids' faces. Buying the freshest, high-quality food for their family at the lowest price. Simply walking the aisles and discovering what's new. New fashion, new cosmetics, new decor, new electronics. It's just plain fun. It connects us, it entertains us, and it's a deep part of American culture. The customers are changing who they are, what they want, and how they shop. And they're definitely busier than ever. Technology is changing everything from how customers shop to how items are sourced, manufactured, and delivered. Sure, retail is transforming at an unprecedented pace, and the transformation hinges largely on innovation. and innovation relies largely on technology. Technology can be a major enabler in how we work as merchants. We are in the middle of a major transformation at Walmart. We believe technology, and machine learning specifically, is at the heart of the transformation that we are driving. All very exciting stuff. But I believe there's also innovation to tap into that's not solely tech-based, and that's where we'll start, at the foundation, the stores, brick and mortar retailing. At Walmart, we've worked for more than 50 years to deliver on behalf of our customers. It's inherent in our company's culture, as well as a relentless focus on everyday low cost, or EDLC. We are investing a lot of time and money into making our stores run even more efficient. Everything from how we get inventory through the supply chain more efficiently, how we get it on the shelves, and to how we check it out is constantly being fine-tuned. It's an exciting time in retail, possibly the most exciting time because it's all converging. Physical and digital, lines are blurring, stores are transforming, customers are changing, technology is enabling innovation that sometimes feels unimaginable. What an incredible opportunity. We get to be the ones to shape what retail will look like in 10 years and beyond. We are determined to bring efficiency to everything we do. We have turned to operations research and advanced analytics to help us deliver this vision. Our team, just like Mr. Sam Walton 50 years ago, is committed to everyday low cost, recommitting time and resources to keep prices low and working to save people money so they can live better. Today, you'll hear from my fellow associates who are committed to the service of our customer by building an intelligent approach to markdowns. The old adage, a penny saved is a penny earned, couldn't be more true for the work we've done by Prakar, Nate, and so many more at Walmart. Technology and innovation have come together in service of our customers. Thank you.
My name is Nate Lyman, and I am a Senior Director on the Walmart US pricing team. Scott walked you through how we think about price and its role in our productivity loop. I'm going to introduce the specific business problem we tackled with an application of operations research and machine learning. A core function of the Walmart merchant is to select assortments of items. These items are arranged on shelves in our stores we refer to as modulars. These modulars help customers find what they need when they need it. As customer preferences change or we transition to a new season, the assortment needs to change. These assortment changes are distributed throughout the year, balancing seasonal relevance with operational constraints. Our focus here is on the items being removed from the assortment, and more specifically, how we price these items. So why do we want to sell the last unit of a deleted item just before the modular transition? It's a balance of customer perception and operational efficiency. If we sell out too soon, customers will find empty shelves in the weeks leading up to the modular transition. Customers finding empty shelves leads to a sales shortfall in the short run and customer trust issues in the long run. If we don't sell out fast enough, store associates have to move the item to a separate location we call a clearance aisle. Store associates moving inventory adds cost and wastes time that could be spent on more productive tasks. Ultimately, product that doesn't sell from the clearance aisle is donated or disposed. So far, I've been referring to an item deleted at a certain date being sold out at the right time, almost as if we have one store. And on a case-by-case basis, with the right understanding of inventory levels, an order cycle, customer demand, it's a fairly simple problem. However, like most things at Walmart, the problem becomes exponentially more difficult at scale. We are dealing with nearly 5,000 locations, each with around 100,000 products, and the demand curves of over 140 million customers every week. Each week, thousands of items are being selected for deletion, and thousands of stores have to make room for new products to better serve these millions of customers. Historically, we've dealt with the problem by using rules to set clearance prices based on 3 combinations of % off discounts at fixed intervals. 3 markdowns means 3 printing labels plus the cost of labor to change these labels. And if there's unsold inventory at the end of the markdown, cost to move it to other parts of the store. In general, it also doesn't leave room for nuance on a store-by-store or item-by-item basis. So why did we start here with this problem to apply machine learning? Several factors made it possible for the clearance pricing application to be the first major machine learning-driven analytics deployment in merchandising. First, we have broad alignment to a concise goal statement. Get out of deleted inventory just in time for new inventory to be merchandised. There's much less room for nuance around what success looks like here compared to, say, evaluating the success of a new item. Second, the initiative has significant and immediate value implications. Every year we spend billions of dollars on clearance prices due to the scale of our store network and the breadth of assortment in each store. Even small improvements in the efficiency of this process are associated with significant savings. And that's before even thinking about the opportunity cost of human time spent managing deleted inventory. We were looking for the solution which can allow us to both in-store and at the home office save time to be spent on more productive tasks. Also, we wanted to develop a solution which can be tested against the established process to prove the value creation and be expanded to our wide store network while accommodating the frequency of assortment changes and keeping the trust of our merchandising partners. Hence, I can say the sheer magnitude of this problem, the complexity of achieving multiple objectives at once, and the precise timing needed to do it surpasses human capability. That's why we operationalize machine learning at scale for this solution. It was key to forge a strong partnership between the business, product, and technology teams involved with this project. From a business perspective, we wanted to provide enough direction to avoid time lost in nuance and semantics, but leave the teams, and especially the data scientists, ample freedom to innovate. To this end, we came up with a set of design principles that add operational guardrails to how we need to achieve this goal. For example, we need merchants and operations to have forward-looking visibility to what items will receive a clearance price and when that price will hit stores. The principles also lay out financial expectations. And now I will hand it to Prakar for more details.
Thanks, Nate, for explaining the nuances of markdowns and why they are important to the company. So by now, it is clear that the problem of markdown is actually a multi-objective optimization in a constrained environment where the objective is to maximize two key metrics, sell-through and clean shelf, by minimizing costs. Let's talk about sell-through. It is defined as a percentage of units sold by the end of markdown period. So for example, consider two stores, A and B, each having 100 units that are needed to be cleared. By the end of markdown, store A has sold 60, while store B has sold all 100. So the sell-through rate for store A is 60%, while for B is 100%. Overall sell-through rate across both the stores is 80%. Clean shelf is a metric that measures a binary outcome, i.e., if in a store we achieve 100% sell-through, did we do so at the right time? So now consider one more store C that also has 100 units and by the end of markdown sold all 100, but they all sold it too quickly. Then in store A, the clean shelf is 0 because we didn't even achieve 100% sell-through. In store C, it is also 0 because even though we achieve 100% sell-through, we didn't do it at the right time. Only in store B, we met the criteria, hence for store B, the clean shelf is 1. So across the three stores, the clean shelf is achieved in 33% of the stores. Now let's talk about the cost, which has two major buckets, merchandising and operations. Merchandising cost has two components, dollar loss to fund the discounts and the loss of original retail due to any unsold inventory at the end of markdown. On the operations side, there is a cost associated with printing the labels and associate hours required in relabeling. So more the number of price changes, higher this cost gets. Next is the cost needed to move the unsold inventory to other parts of the store. This is why 100% sell-through is important, as we will save on this cost. So to recap, increase in sell-through helps you recover capital locked in form of unsold inventory. Doing it in less touches helps reduce relabeling costs. Achieving 100% sell-through gets you saving in cost to remove unsold inventory and avoid waste, while clean shelf helps you with customer perception by not running shelf empty too soon. Next, let's look at the constraints we have. Some of the design principles that Nate described earlier are actually constraints. The most important one is that prices can only go down during the clearance markdown. Then there are some rules related to rounding, and of course there is a clean shelf constraint, i.e. not running out of stock too soon. So it is clear by now that the optimal policy here is a single discount that gets us 100% sell-through and clean shelf by spending same or less in the cost of a rule-based policy. So we need to find this single discount and execute it. Now, if for any case it doesn't work, then we can use second discount as a backup. However, if we overshoot in the single discount, i.e. we go deeper than what is required, then we risk the clean shelf metric as shown here. We can't even correct it by sending second price because as per our constraint, prices can only go down at markdown. This situation is very bad. Now, if we undershoot, then we have another shot. However, when we do this, we also incur relabeling costs. So given the multi-objective nature, we decided to build an algorithmic approach in the following way. For every store item combination, there are two decision variables, price changes and the timing of the price changes. We built two engines, a forecasting engine that learns price demand relationships, i.e. what happens to the future demand when we change the price. We do it in two ways. One, by inputting various variables like historical sales, special event, holidays, etc. into a gradient boosting model. And in the second approach, we encapsulate everything in a variable k and explicitly model inventory decay as a function of price. These price demand relationships are then fed into an optimization engine along with the constraints to estimate two policies, a single touch policy and a multi-touch policy based on a Markov decision process. Then we compare the two policies and select the most optimal one and send it to stores for execution. If single price is not doing its job, we send the second price. If optimizer says start with the two price policy, then we use the first discount to explore across cluster of stores and then explore it at the right time by sending in second update. So the overall complexity of this problem is massive. In a typical week, we need to find markdown policy for about 800 to 1200 unique items. So on any given day, we are roughly doing 3 to 6 million optimizations with peak of around 15 million. Now here comes the fun part. As we were trying to learn the price demand relationships for each store item combination, things got very challenging and interesting. Now Walmart is an everyday low price retailer and promises consistent and low price. It is not a high-low retailer and doesn't do regular promotions, which means that there is not enough price variation in the historical data. Moreover, the historical markdowns were also at a 3 fixed discount, 25, 50 and 75% off, as a result of which it is extremely hard to interpolate what happens in between these 3 price points for different items. So for example, the plot on the left shows relationship between price and cumulative sell-through for 3 different items, with x-axis being the percentage discount and y-axis being the sell-through. You can clearly see a piecewise linear relationship between 3 price points, and the slopes of the linear curve are also different for each item. Clearly, item 3 is not very sensitive to a deeper price change, so marking it down to 75% might not be doing much apart from losing retail. On the other hand, item 1 is highly price sensitive. Now we can of course construct a hypothesis and make assumptions that behavior of these items at other price point also follows the same curve. But we can see from the second plot on the right that this is highly prone to error. Then there is the issue of geographical location of our stores, which are spread out all across US, as you can see in the inlet. Same item will vary differently across different stores. Seasonality also plays a role, and then we have issue of no historical data at all, as is the case with new item markdowns. So hence, to validate these hypotheses and collect more data, we would need to do experimentation in the stores. But experimentation in the stores are expensive, laborious, and have slow feedback. There is dependence on operations as well as a financial liability. We need to explore several policies at deeper discounts and different timings, so there is going to be an impact on the financial plans and budgets already set for the year. Moreover, some experiments might just fail and we might have unsold inventory, hence they might incur additional losses. Then there are other operational challenges to execute such experiments. For example, stores would have to build a process to answer to customers in case they ask why markdown is not falling 25-50% as before. So in a nutshell, this is what we are dealing with. We had to build an algorithm that works in one shot, where cost of making mistake is massive as we can't roll back anything like we can do in today's digital world. Operations have to be aligned because if for any reason experiments didn't get executed, then we will miss a data point from a crucial item that was undergoing markdown. It will delay our timeline. Experimentation is by itself hard and needs to be clever, because if we get experiments wrong, we get financial liability. And most important of all, we risk of losing the trust and momentum that we had at the time of launch of this project. So to overcome these barriers, we decided to reach out to executive leadership, including Scott, who you saw earlier in the presentation, and explain the situation where we are in. We wanted to be data-driven, so we did simulations with whatever data we had to analyze multiple scenarios. We explained them our approach and reason why experiments are crucial. For example, we showed the expected loss in revenue resulting from failed experiments, which are driven primarily by errors in price demand curves. We estimated additional costs needed to fund this deeper discount, and on the bright side, if we got things right, we showed them the expected increase in sell-through we might get. Now, being data-driven helped us gain their trust, and Scott graciously offered to underwrite any losses to the P&L from such experiments, and also align with operations leadership to streamline store execution challenges. This gesture made us feel how valuable and supportive is the leadership towards this effort, and how keenly they want to solve this problem. So we started our experiments in February 2019 in about 1,200 stores. We bucketed all the stores into various clusters and randomly picked few stores from each cluster as treatment. They will get marked down based on our new approach. The rest of the stores were control and would get the same old rule-based policy. The plot shows the evolution of cumulative sell-through with time. In blue is the treatment, while yellow is the control, and we can see treatment outperformed control. Every experiment provided us valuable data that helped us learn store-specific price demand initiatives, which we then fed back into the optimization engine to figure out the optimal single and multi-touch pricing. This feedback loop helped us eliminate policies that might not work and build a robust optimization framework. This also narrowed the exploration space which we need to test, thereby experiments were becoming cleverer and cleverer by every single passing day. We consistently outperform the rule-based policy, as personalization clearly has an impact. These encouraging results meant that by beginning of July, the percentage of treatment stores kept on increasing. There were more stores on treatment than in July, and we continued to expand to more stores as we kept getting our confidence. By end of year 2019, 60 out of 70 departments were running using our algorithm across all of our 4,700 stores. So we believe that this is the first reported work of applications of operation research and machine learning to retail business strategy of a category agnostic system. This means that this approach could be ported to all categories, from foods and consumables to general merchandising to healthcare. What we have essentially built is a framework for pricing under a constrained environment, so it has applications in industries outside retail as well. I now want to invite my colleague John Goy, who is going to talk about product design for this project.
At Walmart, people are used to building fast, scrappy tools in their spare time. Our associates really take pride in ownership when they roll up their sleeves, learn just the right combination of SQL, Excel macros, and alterates. It gets them into the details, and they get a deep appreciation for the problem that they're solving. That's the main reason that the cornerstone of our product design philosophy revolves around earning the trust of our Walmart merchants first. When we talk about large-scale analytical products, people quickly associate that with a big black box. Well, we aim to open that box up for them. We showed exactly what data goes into the system. We educated them on how data science drives the results that they wanted to achieve. And we display the results in business-friendly language that makes sense to a merchant in the context of the work that they're doing. The design of the Markdown product started with this philosophy. Merchants were always a part of our design and development journey. However, there's something more unique and more challenging for markdowns. In essence, this is a problem that is constrained by time. Not only is the markdown window itself fixed, but the execution of the generated recommendations needs labor planning. If for any reason the tool goes down, then it not only disrupts labor, but we also end up losing a day to sell those items. And that's something that we definitely don't want. Markdowns have a high computational complexity. On any typical week, the system has to find optimal solutions for 1,200 to 1,500 unique items across 4,700 plus stores. That's about 2.5 to 6 million computations just for one pass. Once markdowns are executed at the store, the algorithms have to consistently monitor the performance and run optimizations to see if there's need for a second touch. If so, we need to price them again, and that's another 6 million computations. The product and the back-end system powering it need to support user edits. The merchant might decide to mark down one additional item, or maybe there was a last-minute change to his assortment. In either case, the merchant will want to make changes and then understand the impact of his P&L. When these types of changes do occur, the new results need to be available within 15 minutes without impacting the user's experience. Then there's the issue of exception management. Exceptions are always there. A merchant might decide to reject the recommendation and might go back to the supplier to negotiate to preserve that brand. Our product needs to support that. And when it does happen, it needs to capture the reasons for merchants bypassing algorithmic recommendations. Lastly, a very important design element was providing a user interface that takes those 6 million personalized store item combinations and synthesizes them in a way that our merchants can understand. A merchant should be able to easily look at the output and quickly see that one touch at a slightly deeper discount is okay. He doesn't have to go back to the traditional 25% or 50% off. It's all about earning that user trust. Once the merchant is happy with his financials, all he has to do is press a single button to execute. That button locks in those recommendations and sends millions of pricing actions down to the stores. Those prices are displayed on shelves and activated on our point of sale systems. There's always some friendly banter between the product management teams at Walmart. It's not uncommon for someone to half jokingly ask, hey, what have you done today to change the way that Walmart does business? But if you really want to change the way a company does business, you have to invest in a strong foundation, earn the trust of your users, and most importantly, learn from your mistakes. It can take some time, but the results are more long-lasting. If we look back at the evolution of the clearance markdown product, we started it with a really basic objective: modernize a legacy system, and I can proudly say that we did that. I will now invite my colleague Kevin to talk about yet another challenge, user adoption, and he'll also share the results that we've seen by the end of 2019. Thank you very much.
Hello, my name is Kevin Paletti. The results of this work clearly showcase the value of accelerating innovation and moving quickly to test, to improve, and to expand. In my time at Walmart, I've not seen an initiative of this size move so quickly to a broad-based rollout. Typically, projects of this nature are looking at a 3 to 5 year lead time, but this took about 12 months. We tracked 3 primary metrics for this initiative: decreased markdown dollar spend, improved sell-through of inventory, and clean shelves. I'm glad to bring a positive report across all 3. First, reducing dollars spent on markdowns overall means we can reinvest in better prices for the customer. It also directly improves profitability on our current items. Since the launch of this policy, we've seen cost savings up to 7% when compared to the previous rules-based policy. Fewer markdowns also translates to giving store associates time back to serve our customers. Second, improving sell-through of inventory is an industry-wide challenge. Any retailer faces the need to move through old inventory, and those that do it most effectively can free up cash flow for more productive uses. For example, Walmart has been able to invest in new initiatives like pickup and delivery. In record time, this project has delivered a 21% improvement. Finally, the clean shelves metric has improved twofold. This is absolutely vital to our operating model and a key unlock, in part because of the need to leverage store labor. Second, though, if shelves are not clean in time for new items to arrive on the mod, then we could miss sales on those new items. Often, we find store associates having to move and find a place for deleted items that did not sell through by the right date. And this prevents other important tasks across the store from being done. For comparison's sake, I think it's important to know that at Walmart's scale, at least in merchandising, notable improvements often have their magnitude measured in basis points. It was not an easy path to achieve 21% improvement in sell-through and a near doubling of the clean shelves rate. To be successful, any endeavor within Walmart needs a robust change management plan. And we're excited to have an adoption rate over 96%. To be transparent, some management teams were resistant to an approach that they couldn't fully understand at first. There was almost a psychological block. Others were more hesitant to let a data science plan run their entire set of clearance needs right off the bat, without a feel for what probable outcomes it promised. Some had established ways of negotiating these costs with suppliers, which the new method would disrupt. These examples, and many others, helped guide our approach to implementation. From the start, we had great executive support and air covers we tested and slowly evolved our methods. We used these early test results as a guide of what the newly onboarded teams could expect to help increase their comfort levels. A major part of success of this project can be contributed to our initial thought process that helped us to formulate project-specific design principles, which Nate explained earlier in the presentation. We worked hard to involve business teams directly in the development of the algorithm to help take them along in the journey. For example, They help define constraints at a business-specific level. In addition to widespread email messaging, we hosted a website with introduction videos, guides for the product, and a white paper explaining the science. We spent time teaching and training, researching and reevaluating. I've personally met with countless teams and individuals around the company to learn about their specific needs, and then, in turn, spent time with the data scientists to ensure that the model accounts for those needs. As the adoption rate shows, most were glad to move to the new way of working after they caught the vision. Now, we continue to monitor results, connect with business teams, and resolve business-specific challenges in the system. To get these algorithms into the hands of our merchants and into the store systems in such a short period of time, we worked in parallel. The product team developing a clean, simple interface, data science continually testing and refining the code, and our business teams providing immediate feedback. Every time there's a need for a second touch at the store, it acts as feedback into the algorithm. So next time, when a similar item goes into clearance, we'll do it with one touch. A major part of making this work useful comes through the improved financial transparency, operational efficiency, and faster P&L management that it provides. The digital transformation to a web-based product also means our teams get away from error-prone and sometimes cumbersome Excel files. At the store level, price changes still take place, but we're greatly reducing the number of changes per item. In some cases, it'll be half the number of associate touches required previously. This means more time to directly assist and interact with our customers. From a P&L perspective, I can spend my time focused on reducing costs on new items or improving upstream planning instead of worrying about how to price items that I've already decided to delete. This means the money and time is saved and reinvested to better serve customers. Walmart's investment in analytics and operations research is paying off, and it's doing so because we've been able to accelerate change and innovation. In the model, yes, but more importantly, in the execution.
Thank you, Kevin, for taking us on the journey of change management and sharing those impressive results. I now want to invite two of our associates, Brett, who is a merchant and does the markdown planning on daily basis, and Kim, who is a store manager at store 3261, to share their experiences on how their world has changed after the rollout of this algorithm.
Hi, my name is Brett Reed and I work in merchandising as a senior planner. The data science model is helping me and my team save on markdown dollars. It's helping drive efficiencies in the business to understand risk that we would not be able to see previously. It's ultimately spending markdowns smarter and more effectively. Previously, we would take markdowns to the same retail across the nation. Now the data model provides us retails that are unique based on the variables to a store level. In the past, we would use Excel spreadsheets that potentially had missed items and inconsistent formulas. I don't have to worry about that now. The data model captures this and rolls it up for me. In my job, I'm evaluated on sales, profit, and inventory. This model benefits each of those. I'm able to increase my overall sales dollar value by understanding when to take certain markdowns. Because I don't have to take markdowns as deep, it helps me save on profit. I'm able to effectively reduce the risk of my overall inventory and help turn through product. Having data at my fingertips help me not pull from 3 different sources in order to make one decision. It also helps the stores with store labor. Thank you.
My name is Kim Pierce. I'm a store manager for store 3261 in Richland, Washington. I've been with Walmart for 20 years. Running stores is both fun and challenging. As a leader, I have to make sure that our customers get what they want and have a great shopping experience. As a store manager, I have to keep exploring innovative ways to save costs in line with our everyday low cost philosophy. Labor costs and printing costs contribute largely towards the overall operating cost and increase during markdown runs. By the approach to markdowns, this is a game changer when it comes to reducing costs and managing associate schedules and running stores more effectively. Guarantee of less markdown touches has helped me plan labor more efficiently. The print label costs have gone down, and the need for inventory to be moved across different parts of the store has also reduced dramatically. Since we rolled out algo-based markdown plans, we were able to sell more items. In all, it's been a positive impact to the bottom line. I'm glad we made this change. It's one less thing that I have to worry about, allowing me more time to focus on innovations that will allow us to better serve our customers.
Thank you, Brett and Kim, for sharing your valuable experience. One thing I want to mention is that during this unprecedented time of COVID-19, having the ability to clear the modular by one touch is just a blessing. The associates don't have to go and reprice multiple times. We don't have to move the items in different parts of the stores. It just everybody feels safe.
Quicker off the shelves, providing a better value to our customers and allowing the associates to spend more time helping those customers instead of pricing and moving product around. It's been very beneficial with the COVID situation right now because now our associates have time to do the proper cleaning and everything else that we were required to do.
Before I invite Scott for his ending thoughts, I thought it would make sense to have a quick recap of what we have learned so far in this presentation. Here is a video that summarizes it all for us. Thank you.
Thank you to the group for presenting about markdowns. By now, I'm sure that we've been able to showcase the impact that rolling out the dynamic markdown algorithm has had on our business. I'm proud of the project for many reasons. It made a big impact on the bottom line, but it was also a great learning experience for us. It proved that we can bring automated decision-making, powered by analytics and operations research, to an enterprise of our scale in a very fast timeline. In fact, it taught us the key ingredients for future efforts. We know that we now need top-down support, we need to bring stakeholders along on the journey, and most importantly, we need to continuously learn from experimentation. It was great to see scientists and business teams working together. We taught scientists the nuances of retail and the constraints of our business, and in return, the scientists taught us how to leverage data through experimentation. I'm immensely proud of our team who accelerated this rollout and made sure that along the way, merchants and planners were aware of what was going on and were prepared for the change. They developed an interactive and user-friendly product which gave merchants confidence to adopt the new system. And at the same time, we preserved the very essence of the algorithmic recommendations. Finally, the work presented here not only makes an impact on the bottom line of the company, but it streamlines operations in the Walmart home office as well as our 4,700 US stores. Most importantly, it helps our customers save more money. Save money, live better. That's our motto. Thank you.